Hello everyone, thank you for registering and coming to this webinar. My name is Cristina Gomez and this is our special technician Graver Santana. And today is the webinar that we have, and if you have any question, you can post them in the chat, and don't worry, those that are not answered will be answered by email. So, okay, Graver, your turn.
Hello everyone, my name is Graver Santana. As my colleague said, I'm gonna be showing to you guys our software solution to design an electrical installation. So I would like to tell you that we are gonna be working on a BIM environment. In order to do so, we are gonna be uploading all the information to the cloud. And the platform that we're gonna be working on with is gonna be the BIMserver.center platform. And here what we're gonna be able to do is to see all the projects that we have created, our contribution to those projects, and the project that other people have shared to us. Before that, I would like to show you that this is going to be the workflow, and these are the software that we are going to be working with, so we can design our electrical installation. I would like now to show you here in the BIMserver.center where you are going to be able to download the software that we have. For example, if you click in the store, you're going to be able to see all the software that we had so far. For example, now we have 172 software, and if I click in the electrical installation here, you're going to see all the software that we have for the electrical installation. So I'm just going to click in one of them so I can show you how to download it. By clicking in here, you're going to be able to download the software of your need. And then if you want to see more information about any of our software, you can click on the application website. Here what you're gonna see is the detailed information with more information about the software, the learning resources, where you're gonna be able to see some video of how to use the software, and the FAQ with answer to common questions. Just gonna go back to the workflow. In here, I'm gonna tell you that in order to start working with it, as I said before, we are gonna be working on a BIM environment. So it means that we are gonna need an ISC file that can come from any of these sources. For example, here we have the CYPE architecture. As you can see, this is a software that we have created for the architectural drawing, and where we are going to be able to generate an ISC file.
And I have a question. Do we need the IFC file to come from CYPE software, or can they come from other ones?
No, the ISC file can come from any other software. For example, here we have the plugin for Revit, so it means that if you're working in Revit, you are going to be able to install this plugin, so you can export that information to the BIMserver.center, so then we can start working with our software. Then another way that you can do is that if you are working with any other software, for example, Allplan or Archicad, you can get the IC file, and then you're gonna be able to upload it to the cloud by using the IC uploader.
I see. So if you have an IFC, you can work with other software. But if I only have a 2D file, how can we work with them?
Yes, if for example your client sends you a 2D file and you're gonna have to generate the ISC building model. So in order to do so, you can use the ISC builder, which is a software where you can generate the 3D IFC building model of your building with a simple steps. So there's no limitation in it.
Oh, great.
So the project that we are going to be working on today was designed on the CYPE architecture. So the first thing I would like to show you is to open the CYPE architecture, so you can see the project that we are going to be working with. As you can see now, here I have the CYPE architecture open, and this is the house which we are going to be working to design our electrical installation. So if I go to the third floor, this is a single family house with 4 bedrooms, as you can see here, with a living and a dining room, a kitchen and a garage. And then we have here in the outside a garden and a pool, as you can see. Then in the second floor, we are gonna have a studio. All right. So let's say that we have finished our architectural drawing. So the first thing that we are gonna need to do is to click in here so we can connect to the project that we have created in the BIMserver.center. And then once we are done, we can share that project so then we can open it in the software that we are gonna do our design. In order to do so, the first software that we are gonna be working with is the CYPELEC electrical mechanism. In this software, basically what we're gonna do is that we're gonna import the model that we have created in the CYPE architecture. After we import it, what we're gonna do is that we are gonna introduce all the elements. For example, here we are gonna introduce all the lighting, the switches, and the electrical outlets, as you can see here. And then once we introduce them all, what we have to do is to calculate. And after we calculate, we are gonna see some warning. For example, here I have a warning that I'm not meeting all the requirements. So if I click on console the checks, I'm gonna see what does it means, and what it means is because I need 7 electrical outlet as a minimum for the kitchen. So and I have already installed only 6, so I'm gonna need to install 1 more. That's a configuration can be set if you go to the general option, and if you go to the point of use. Here for the kitchen, for example, you're gonna see that the number of units that I'm gonna need are gonna be 7. So if I go back and then I go clicking here, what I'm gonna introduce now here is an electrical outlet. Then I'm gonna introduce also a TV outlet. And also I'm gonna introduce a phone jack outlet because this is gonna be an outlet for a TV. Then I'm gonna introduce it in the 2D view, and I'm gonna introduce it in this displacement. I'm gonna introduce it in here. I'm gonna rotate it. And if I go to the 3D view, this is how it is going to look like. All right, so I'm gonna go back to the 2D view, and now I'm gonna just calculate it again. Once I calculate it, the warning message that I have here has disappeared. So if I consult the checks now, as you can see now, I'm meeting all the requirement. This information can be exported in any type of this format, so we can get the reports of it, and then we can do so for the rest of the spaces that we have here. As you can see, after we have completed our installation, one thing that we are gonna be able to get are gonna be the drawings. Here by selecting the floor that we want to print, we're gonna click on accept, and before clicking on accept, I'm gonna show you that here these are all the formats that where you can print your drawing. For example, you have here the DWG and the PDF. I'm gonna print them in PDF. Okay.
Well, so all the drawings are automatically generated by the software?
Yes, that's right. So the only thing that you're gonna need to do here is that you're gonna have to select all the floats that you want the software to generate, and then the software is gonna start generating them, as you can see now. So now the software is generating the ground floor. As you can see.
You don't need to do nothing more, right?
No, you don't need to do anything else. So the software is gonna generate it automatically.
Oh, great.
All right, now it is printing the ground floor. I'm gonna click on yes. Then if I click on detail all of the drawings, as you can see here, for example, if I take a look in this one, here you are gonna see the legend with all the symbols that we have introduced. Then here you are gonna have the electrical installation for the studio that we have in our house. And then here in the first floor, we are gonna see all the elements that we have introduced, as you can see. After that, what we're gonna have to do is to share that information so we can start working with the next software, and the next software is gonna be the CYPELEC distribution. In the CYPELEC distribution, what we are gonna do is that again, we are gonna open the IC file that we created on the CYPE architecture, and we are also gonna import the the elements that we have introduced in the previous software. And here, the first thing that we need to do is to introduce all the type of lobes that we are going to have and the power of them. So then we can assign them to all those elements that we introduced in the previous software. After that, what we have to do is to calculate. And by calculating it, for example, I have half of the installation already designed. And as you can see here, I have an error message, as you can see below in the right corner. And if I get close to it, it said that I must assign it to a circuit. So what I'm going to have to do is that I'm going to have to edit it. I'm going to assign it to a switchboard. So I'm just going to be assigning it to this distribution board and then to a circuit in this distribution board. So I'm going to assign it to a circuit 1, which is the one for lights. Now I'm going to have a different error message, and it said that I'm going to need to connect it with a conduit. So I'm going to select the conduit, and I'm not going to fill any of the information here since the software is going to do it automatically. And I'm going to introduce it now in the 3D view so you see the difference of it. And I'm going to connect it with this conduit that you can see here. All right. Hold on. I'm going to have to change it. I'm going to connect it again. Just going to have to connect it with it. Let's gonna connect it in here, and then what I'm gonna do is that in here, if I calculate again, this circuit is gonna be assigned to this conduit automatically, as you can see. So now that I have calculated again, have no error messages in here, and then I'm gonna be able to share that information. But before sharing that information, I'm gonna show you what I have introduced here. What I have introduced, the first thing that I have introduced in this project is that I have introduced the SP1, which is gonna be my connection to the grid. And as you can see, since this is gonna be my connection to the grid, this is gonna be outside. And then I have connected it with the distribution board that I'm gonna have in here. And then from this distribution board, I'm gonna have the load connected, and I'm gonna have a distribution panel here in the kitchen, as you can see, connected to the distribution board. And the distribution panel is gonna be for the kitchen and for the outside, right? So after I have finished my installation, I have no error message, I can click in here and I'm gonna get my report. The report is gonna be divided by switchboard and by the circuit. So if I go down to it, you're gonna see here that I have the distribution panel and all the circuit that I have connected to this distribution panel, the type of loads that I'm gonna have, and the power of each one of them. Then below that, I'm gonna have the distribution board, as you can see here, and all the circuit that I have connected to that distribution board. Then below that, I'm gonna have all the circuit detail, the detail of all the circuit with the type of lobes, the power of them, and the total number of units and the total power, as you can see here. That information can also be printed again to any of these type of formats, as you can see here. Then after that, one more thing is that again, I can get the drawings here. I'm not gonna do it now because it's the same thing that we do in the previous software. So I'm just gonna keep going. Once we have finished it, what we're gonna have to do is to share that information so we can go to the next software. And the next software we are gonna be working on with is gonna be we are gonna do the grounding. We are gonna calculate the grounding resistance of our installation. So in order to do so, we have these two software, but I'm gonna use this one, the CYPELEC grounding ISC. Okay, so what I'm gonna do is that I'm gonna open this software. And what I have to introduce here is that I'm gonna have to select the resistivity of the soil. Here we have the different type of soil that we can have in a installation. And those type of soil come with a default resistance, but that comes by default, but you're gonna be able to change it if you know the exact value of it. Then you are gonna have the total length of the berry conductor that you're gonna have in your in your installation. And if you're gonna have any combination of electrode, you're gonna be able to introduce it in here. Then below here, you're gonna see the grounding resistance of the installation. So it is gonna get calculated according to the information that you introduce in here. So let's say that we are gonna be working on a soft limestone. So as you see, if you go down here, it has changed because of the resistivity of the soil that I have. Then in the right, you're gonna see the calculation that the software has carried out according to the information that I have introduced. And here you're gonna see the grounding resistance of our installation. That information you're gonna be able to print it from here, or if you click in here also, you're gonna be able to export it again in any of these type of formats. All right. So
I have
yes,
a little question. Can you get back to the workflow?
yes.
Please?
Here.
Yeah, earlier you said that you had the possibility to use these two software for the grounding system, right? What is the
Yes.
difference between the two of them?
The difference between these two software is the standards. For example, this software is according to the ISC standard, and this one is according to the standard 80 of the IEE. So basically, the two software, they do the same. This one is according to an European standard, and this one is according to an American standard, but they are pretty similar and they do the same.
Okay, thank you.
You're welcome. So the next step that we're gonna do is that now we are gonna start working with the CYPELEC core. And in the CYPELEC core, basically what we're gonna do is that we are gonna generate our single line diagram of our installation. So here, as you can see, I have imported all the information that I have introduced in the CYPELEC distribution. For example, if I click in the circuit 1, you're gonna see the demanded power that I have here and the total length of the conductor of that circuit, so we can calculate the voltage drop. All right. So the first thing that we need to do here is to click in here so we can generate the single line diagram. Then the software is gonna ask us if we want to generate it. This is how it gets generated, the single line diagram. As you can see, this is so big because we have the standard loads. As you can see here, the distributed load that we calculated in the CYPELEC distribution. But if you want to see a smaller, for example, by clicking in here, you can contract that information. So it's easier for you to work on the software. After that, we are gonna be able to calculate and to do the analysis of our installation. Now it have initiated the process. And now we can see all the error messages that we can get. For example, if I click in this one, and we go to any one of them, I'm gonna see it on a preview so you can see bigger. And what I have here is that this is gonna be the design current of our circuit, this one. And this value has to be the same or below the nominal current of the protection device, as you can see here. And the protection device that is selected so far is an automatic switch of 10 milliampere. So this one is below this one. And then the minimal permanent current of the cable needs to be more than the protection device of the same. So that's one of the things that we're gonna need to fix. So if we go back here, we can see now that, for example, by clicking in the design button, what we're gonna do is that by selecting all this information here and setting all the requirements, the software is gonna correct most of the error automatically. So we are not gonna need
one
to.
question.
Yes.
Do you say now that the software correct automatically, but they correct all the errors, or do you need to add something, make it manually?
Yeah, most of the error, the software is gonna correct them automatically according to the parameters that we are gonna be setting here. But there are some things that we are gonna need to check them. So, for example, I'm gonna show you now. If I click on a set, you're gonna see that most of them are gonna disappear.
Okay.
And for example, here we only have one error left. And if we go clicking here, It is because of the selectivity. That's something that a software cannot do automatically. So we are gonna need to do it manually, because here we are gonna have to take a decision, you know. So here, this is the error that we have. But if we go down, here, the software is gonna give us a decretion of the error. So it said that's because that downstream we have an instantaneous device for the residual current protection. So it means that upstream we are gonna have to change the type of protection that we are gonna have. Then the other error that we have is because that also that downstream we have a residual current device with a current of 30 milliamperes. So we are gonna need to change it because it cannot be the same. So
do you mean that the software not only analyze but also detect the errors and correct them, and also explain them to you why you have an error?
The software analyze and correct most of the error that it can do automatically, but there are other ones that you're gonna have to do them manually. And in order to do that, the software tell you how to fix it, and then you're gonna have to take a decision of how to do it. All right.
Unbelievable. Thank you. Okay.
So what you're gonna see is that we're gonna have a residual current device with a current of 30 milliamperes, and it is gonna be instantaneous. So it means what the software is telling us is that here we cannot have the same protection, the same residual current device as you can see here. So what I'm gonna have to do is that I'm gonna have to edit it. I'm gonna have to increase the selectivity, and then in here in the type, I'm gonna have to select selective. Then by clicking here, I'm just gonna update the result. And this is what you can see now. Now we have our single line diagram, and now we have no errors, so we can keep going with our installation.
Okay, I have another question.
Yes.
Early, you say that we imported the information from the previous software, right? Where can we check this information?
Yes, for example, the information that we have, if I go back here, we have imported the information from the CYPELEC distribution and the information from the CYPELEC grounding ISC. So the information from the CYPELEC distribution, you can see then in here, as I was showing you before, the active power that you're gonna have and the total length of the circuit. And then the information that we had imported from the grounding software, we are gonna have then in here. For example, as you can see here, the grounding resistance that we are gonna have and the resistance of the soil is gonna be according to the one that we have in the previous software. As you can see here, it's the same information. Okay.
Okay.
So after that, what we can do is that, for example, now one more thing is that you can set, for example, the type of supply that you're gonna have. And here you can have a low voltage network, which is the one that we have selected. And then you're gonna be able to select an electrical substation, a generator, and another external supply. And you can set all these parameters in here. Then one thing that we can get, I'm just gonna calculate it again so we can print the report.
Okay.
And then if we go clicking here in the report, these are we're gonna see the two type of report that we can get. We can get the material schedule and we can get the result table. I'm just gonna click in the result table. And here you're gonna have how you wanna see this information, if you want to join it or joint or separately. So by clicking then in here in the report, you're gonna.
So, but I'm saying that in all the softwares, you're pulling the reports. Do you also pull them automatically?
Yes, the report, they get generated automatically, but before doing that, you are gonna have in here in the result table, you are gonna have to select all the information that you wanna see in the report. So the one that I have selected here is the information that I'm gonna have here when I select the report. All right.
So do you need to write nothing? You only need to select what the information that you want to have in the report, and the software do it automatically.
Yes, if you have designed your installation, the software is gonna generate them automatically. For example, here for the SP1, and the SP1, if you remember, is the connection to the grid that I show you here. I show you in the CYPELEC distribution. As you can see, all this information is connected. In the SP1, I'm gonna have the power that I have calculated in this installation, and then I'm gonna have the total length, and then I'm gonna have here the type of the conductor that I'm gonna have and the section of it. Then here I'm gonna have the current of the circuit, the design current of the circuit, and the current for the conductor, and the voltage drop that we're gonna have in this part of our installation. Then if we go down here, you're gonna have the same information for the connection to the grid and for the distribution board that we're gonna have here. And then if we go down here in the distribution board, we're gonna see all the circuit. And if we select, for example, the first circuit, we are gonna have the power that we have calculated, which is gonna be according to the simultaneously value that we have introduced in here, the total length of it. And then we are gonna have the type of conductor and the section of it. Then here we're gonna have all the same information again that we have in the previous one, the current, the nominal, the current of the design of the circuit, and the current of the conductor and the voltage drop. Then if you go down here, by circuit, you are gonna have more information. Again, you're gonna have the design current of the circuit, the nominal current of the protection device, the current of the conductor, and the maximum short circuit current, the breaking capacity, the minimum short circuit current, and the rest of the information, as you can see, for each one of them. Then below that, we're gonna have here the distribution board that we have in the kitchen with the same information for all of the circuit that we have in the distribution board. And again, that information is gonna be, you're gonna be able to export it in any type of these formats that you can see here. For example, you can export it in PDF. Okay, now one more thing that we can get here are gonna be the drawing layout. And if you click here, you can get the drawing according to the configuration that you're selecting here. And I'm gonna select here the detail of the distributed load that I'm gonna have. And by accepting it, it is gonna generate a single line diagram, as you can see in the detail. And if I get a closer look, this is gonna be our single line diagram, but as I selected the detail of all the circuit, for example, this one here is gonna be the circuit, as you can see here, and I'm gonna have here the detail of all the loads that I'm gonna have in this circuit, as you can see. And for the single line diagram, which is the important thing in here, you're gonna see that I have all the information according to it, with the voltage drop, and that we're gonna have here, the nominal current that we have, the protection devices that we're gonna have here, as you can see. Then, for example, if I go down and I see, for example, this is gonna be a circuit for an electrical car charger. And if I go down here, let's see where it is. And if I go down here, for example, you're gonna see that this is the circuit for the electrical car charger. And this is the circuit breaker that I'm gonna have. Then I'm gonna have a fuse. Then I'm gonna have an electrical meter. And then here, I'm gonna have a residual current device. Then below that, I'm gonna have the connection so we can charge the car, which is gonna be in the garage, as you can see. All that information can also be printed. So after that, what we're gonna have to do is to share that information so we can open it in the next software. And the next software that we're gonna be working with are gonna be the CYPELEC multiline and the switchboard. For example, first thing, I'm gonna open the CYPELEC multiline. And this is a really simple software. By importing the information from the CYPELEC core, what we're gonna do is to generate the multi-line diagram with all the information that we want to include. For example, in this multi-line diagram, I only wanted to include the electrical outlet and these two loads for motor. This one is gonna be for the door of the garage, and this one is gonna be for the pump of the pool, so you can see. Then also that information, if I wanna add some more elements here, I'm gonna have all the elements, because this is software where you can, this is an schematic software, so you're gonna be able to add all the elements that you need. So then that information, you're gonna be able to print it in here again. This is how it is gonna be generated. And as you can see now, this drawing, you're gonna be able to print it. Just like in the previous software, you're gonna be able to print it in any of this type of format. Then the next software I would like to show you is gonna be the CYPELEC switchboard. And in this software, basically what we are gonna do is that we're gonna have to design our distribution board. As you can see here, then here we have the distribution panel, and below that I'm gonna have here motor magnetic starter for the pump of the pool. So I'm gonna go here so I can show you how to work in it. In the distribution panel, for example, here I have that I cannot add more elements, but if I delete one of them, those are the ones that I have imported. As you can see below that, I'm gonna have an error message. So now I'm gonna be able to add more elements. And by clicking here, and I'm gonna have only one element, which is the one that I just deleted. So I'm gonna select that one. I'm gonna place it in here, and the software is gonna tell me that there's no more element left to place. Okay, I'm just gonna accept it, and then I'm gonna be able to print the drawings. These are the drawings that we're gonna get. We're gonna have a legend with all the information according to the protection devices that we're gonna have, and then also that information we're gonna be able to print it. So once we have finished with this one, where we are gonna go is to the CYPELEC network. And in this software, what we're gonna do is that we're gonna import all the information from the low voltage single line diagram that we have done before in the previous softwares. This software is gonna be to do the low flow and the short circuit analysis of an electrical power system. Here what I'm gonna do is that I'm gonna analyze the urban network of the high voltage or where our house is gonna be connected. So first thing that we have here is that we have a connection. This is gonna be our supply, and we are gonna have an nominal voltage of 11 kilovolts. Then we are gonna have a boost in here, and also we are gonna have a transmission line, and that transmission line is gonna be, this is gonna be the type of conductor for that transmission line, and it is gonna be placed on a transmission tower, as you can see here. Then if I go down, I'm gonna see all the checks that the software is gonna perform. For example, here I'm gonna have the maximum voltage drop that I'm gonna have for that transmission line. Here I'm gonna have the ampacity of the conductor that I have and the nominal current of that circuit. Then here I'm gonna have the calculated voltage drop that I'm gonna have. So this one is below the 5%. That's why I have the checks. Also, if I want to see more information, I can click in here and I can consult the checks. As you can see here. All right. Then here below here, I'm gonna have the voltage drop that I'm gonna have, and I'm gonna have the efficiency of the conductor that I'm having. Also, if you want to export that information, you can do so also. So if I go back here, then we are gonna see that here we are gonna have a transformer, so we can transform from the primary voltage that is gonna be our 11 kilovolt to the secondary one, which is gonna be our low voltage installation, where we are gonna be transforming our power to 400 volts, as you can see. And then below that, we are gonna have the another bot and the rest of the installation. For this analysis, I have introduced 2 load cases, as you can see. And those 2 load cases, the first one is gonna be that I'm gonna be providing the installation only with a general supply. And then for the second load case, I'm gonna be providing the installation with a general supply and with the generator. So I'm just gonna go back and I'm gonna go and calculate the load cases. I'm just gonna calculate the low flow. I'm just gonna do the low flow analysis. I'm gonna select the 2 load cases. As you can see here, I'm gonna accept it. I'm gonna click on update the result. And now
you have an error.
Yes, I have an error message here, as you can see, and this is because of the voltage drop.
How can you fix it?
That's because of the voltage drop. Before fixing it, I'm gonna just show you the reason of it. I'm just gonna see in the percentual unit. Okay. So if I see it in percentual unit, as you can see here, I have 95%. Here I got 92, and here I got 90, as you can see.
Okay.
So that's because of in my general option, for example, I have selected here in my configuration that one of the checks that I want to perform is that this is gonna be the minimum voltage drop and this is gonna be the maximum that I'm gonna allow in my installation. So since this one is 95, it's within the limit, but this one is 92 and this one is 90. So these 2 ones are below the minimum one. So I'm gonna have to do something to fix it. But before fixing it, I want to show you how this installation is gonna behave when we analyze the second load case. So now in the second load case, I'm gonna have the general supply and the generator. So if I calculate it now with the second load case, as you can see now, I had 97 and I had 96. So that's because now I have connected the generator and my voltage have increased. Here, as you can see, I have 100% because this is gonna be 400. As you can see, this is gonna be 400 watts. This is gonna be 391. And this is gonna be 384. Okay, so then if I wanna see the report of it, I can click in here. I'm gonna see all the information, and again, I'm gonna be able to import it in here. But if I wanna see detailed information, I'm gonna have to click on the low flow analysis. Here for the load cases, the first thing that I'm gonna have is that I'm gonna see the 2 load cases that I have, and as I told you before, for the first load case, I'm gonna be working only with a general supply with no generator, and then for the second load case, I'm gonna have the generator and the general supplies. So according to that information, then I'm gonna calculate everything. As you can see here, I'm not meeting the requirement because this one is below the minimum. As you can see, that information, if you want to print it by clicking in here, you're gonna be able to do so, and you're gonna be able again to print that information in any type of these formats. Okay, then for the cable and the conductor, this is the ampacity that you're gonna have for the conductor, and this is the ampacity that you're gonna have in each one of the circuits for both load cases. Then I can change the information that I want to display. I can change it by the maximum voltage drop and the maximum error between the nominal voltage and the operating voltage, and also that information can also be printed from here. Then according to the loads here, for example, here we're gonna see the loads that we're gonna have in each one of the load cases. As you can see.
Have those loads been imported from the previous software, the CYPE electrical core?
Yes, those loads has been imported. Sorry that I didn't show you that before. For example, if you go to the terminal elements in this one here, you're gonna see these are gonna be the loads that we have imported. And as you can see, the first one that I see here is gonna be the SP1, which is the one where we have been working on. And for this load, as you can see, the information, I'm not gonna be able to change that information because I'm importing this load. So if I wanna change it, I'm gonna have to go to the previous software and change it in the previous software and then import it again. All right.
Okay. Yeah,
so
thank
one
you.
more thing. You're welcome. So one more thing that you can do is if you wanna add some more loads that have not been imported, by clicking in here, you're gonna be able to introduce if the type of connection that you're gonna have, if it is gonna be a 3-phase or a single phase. Then you're gonna have to introduce the nominal voltage and the power. You can introduce it in the apparent power, the active power, or the reactive power, and the software is gonna calculate the rest of it. Okay. So if I go back here, I was here in the loads. This, for example, in this case, I have introduced 11 loads. So it means that the urban network that I'm analyzing, I'm gonna have 11 houses connected to this network. And again, also, I'm gonna be able to introduce to print the information, sorry. Then here I'm gonna have the type of supply that I'm gonna have for the first load case. As you can see here, I'm only gonna have information for the supply because I'm not gonna be working with any generator. And for the second load case, I'm gonna have both of them. Then this is gonna be the information of the protection device. For example, this is gonna be the nominal current of our circuit. This is gonna be the nominal current of our protection device. And this is gonna be the nominal current of our conduction. And as you can see here in the second log case, I'm not gonna have information because here, let me show you. Because here I didn't introduce any conductor. I only introduced a switch, so that's why I have no configuration for it. All right. Then after that, what we have to do is to do the short circuit analysis. And to do so in the short circuit analysis, we are gonna have to go click in here, and it said the analysis must. Okay, that's because we have to select here all the boxes that we are gonna be doing the analysis. I'm gonna accept it, and now I can calculate it.
Oh, what does this warning mean?
I got a warning message in here, but before doing anything, what I'm gonna do is I'm gonna go back here, and I'm gonna analyze again the fair load case that I have here. Just gonna calculate the fair load case for the load flow. First thing that I'm gonna do is that I'm gonna fix the voltage drop that I have here. So in order to do it, what I'm gonna do is that I'm gonna go to the transformer, and I'm gonna go to the top of the transformer. And in this transformer, I'm saying that I'm gonna have 21 taps. So what I'm gonna do here is that I'm gonna change the tap so I can increase the voltage that I'm gonna have. Okay, now if I calculate it again, for the first load case, this is a voltage drop that we're gonna have. For example, now here we are gonna have a 2%, and in this one we are gonna have around 4%. So now if we console the checks and we go to the boxes, we'll see that now this one before that we wasn't meeting the minimum, now we got 90A and 90C. So it means that we are losing in this one only 2% and in this one around 3.5%. All right. So now I'm gonna go back to do the short circuit analysis just in case. So now Now, if I click here where I have the warning message before, we can see that now it's being calculated, and now I'm gonna have here the cutoff power, which is gonna be 50 kilovolts. All right.
Okay, so the
And this,
warning was because you forgot to correct the last error, right?
yeah, the warning was maybe because I forgot to correct it, or because I didn't have introduced the cutoff power of the protection device that I have here.
Okay, perfect.
So once I do the short circuit analysis, one thing that I can do here is that here I'm gonna see the three-phase short circuit current. So I'm gonna have 4.25 kilo amperes. But if I wanna see more information, I can click in here, and I'm gonna be able to see all the information according to the load case that we are analyzing. So I'm gonna see the three-phase short circuit, the two-phase short circuit. But if I wanna display it on the screen, by clicking here, I can select the type of short circuit that I want to analyze. For example, here I have the two-phase short circuit, I have the two-phase with an air connection short circuit, and I have the single-phase short circuit with an air connection. But if I click in here, I can see all of them. As you can see, I can see them by phase, and I can see the maximum short circuit and the minimum one, as you can see. Also, that information, we can get that information by clicking in here. And here, for example, for the phase A, what I'm gonna see is that I'm gonna see the maximum and the minimum short circuit. For example, for the first A, the maximum short circuit is gonna be a three-phase short circuit, and the minimum one is gonna be a single phase with an air connection. And then the rest of the information, I'm gonna have them for the rest of the phases that I'm gonna have, as you can see here. And also that information, I'm gonna be able to export it in here. Okay. So I'm just gonna go back. Once I have completed my analysis, one thing that I can do, as you can see, is that you can print the report. There is other report that you can print here, and it's gonna be the report of the library of the cable and the report of the library of the transmission lines. But then if you want to print the drawing layout, you're gonna have to select them in here. For example, the low flow. I'm gonna select that one, and the one for the short circuit. So we can do a facts. Okay. And now the software is gonna generate the two single line diagram. For example, here I'm gonna have the one for the load flow. As you can see, with all the information that I have calculated.
Yeah, this is as the other software, the drawing, right?
Yes, that's right. It's generate the drawing automatically. And now here you can see the short circuit analysis with all the type of circuit, the short circuit that I'm gonna have in my installation, right? One more thing that I haven't shown you is that I can calculate a short circuit for example, in this transmission line, I can calculate a short circuit in a specific point of the transmission line. So this is a transmission line of a length of 12 kilometers. So if I set here that I'm gonna calculate the short circuit of 50% of the transmission line, means that I'm gonna calculate the short circuit at a distance of 6 kilometers. Okay, so I'm just gonna select it, and then here in the short circuit, I'm gonna select this one so the software can calculate it. And this is how we are gonna see the short circuit analysis that we are gonna have at 6 kilometers of the transmission line. Okay, so once we are done with this software, what we are gonna have to do is to share that information, so that information traveling to the BIMserver.center. I'm gonna go back to the load flow, and here what we have done so far is that we have seen all of the software, and the ones that we have left is the CYPELEC PV system. And in this software, basically, as its name said, what we're gonna do is that we're gonna calculate the the photovoltaic installation of our house. I already have calculated most of it. I already have introduced all the elements, but if you're gonna start working with this software, the first thing that we do here is that we're gonna have to select all the elements for the library. For example, here we are gonna have to introduce all the photovoltaic panels that we are gonna have according to the data sheet of our manufacturer. There's some information for the battery, the regulator, and the inverter. Then here we're gonna have to select all the general condition, the general option, the maximum admissible voltage drop that we're gonna have, the orientation with respect to the node, so we can calculate the losses that we're gonna have, the minimum autonomy of our installation. This is gonna be for off-grid installation. Then here we're gonna have to select all the design conditions that we have here. And in here, what we're gonna do is that we're gonna have to introduce all the daily radiance value that we're gonna have, so we can know how much energy that we are gonna be generating. In order to do so, you can introduce it manually, or you can import it from a file of the PVG website that you can see the derived assets here. Okay, then one more thing is that you can consider the efficiency of the installation here, so we can get the energy performance. Then after that, what you're gonna have to do is that by selecting here, you're gonna have to select the type of the photovoltaic module that you're gonna have. Okay, here, for example, if I select the horizontal plane, you're gonna see how it is gonna be changing according to the one that you selected. So I'm just gonna select this one so I can show you, and I can introduce it in here. Then I'm gonna be able to connect it with a conduit. All right, I'm just not gonna do it now. I'm just gonna delete it, and then I'm gonna calculate it. So we see I'm not gonna calculate the energy that we're gonna be generating. And we see that now we have an error message in here. So what I'm gonna do is I'm gonna go to the first floor where I have my inverter in here. And the error that I have is in the connection between the inverter and the distribution board. So if I click in here, I'm gonna see which is the error that I have. So it means that I'm gonna have to change the protection device current. So I'm just gonna edit it. I'm gonna go to the circuit breaker that I have, and I'm gonna select 32. I'm gonna accept it. I'm gonna calculate it now with the power that I'm gonna be generating. So that's it. So if we go to the 3D view again, this is how we are gonna see this information. All right. More thing is that if I click in here, I'm gonna see all the losses that I'm gonna have due to shading. And due to shading, I'm not having any losses because, as you can see here, there is nothing between the panels. Sorry, there is nothing between the panel and the sun. All right. So after that, I'm gonna be able to print the report, the justification of the calculation. For example, if I click in here, I'm gonna be able to see it. And if I go down here, these are the losses that are gonna have due to the orientation, the inclination. And then here I'm gonna have the losses due to shading. As you can see, this one is close to 100% because I'm not losing any energy. And then here you can see all the energy that we are gonna be generating. So what I'm gonna do now is I'm gonna move one of them so you see how much energy we are gonna be losing. I'm gonna put it behind here so we can see. I'm not gonna edit it. It's gonna edit it, so hold on. Sorry. Because I want to change the size of the conductor so I don't have problem with the voltage drop. And now if I calculate it again, you're gonna see that I'm gonna have some losses due to this construction element that I have here. So if I click in this panel and I see the losses that I'm gonna have. These are the losses that I'm gonna be having due to the shading that I'm gonna have because of this contraction element. So if I go back to the report, we are gonna see the energy that we are gonna be losing, and as you can see here, I'm losing like around 16% of the energy, as you can see. So then we're gonna have another type of report here that you can have also the design procedure if you want to add it to your report, and you can have the production summary also that I'm gonna print them now. All right, this is the energy that I'm gonna be producing each month, and then I'm gonna have the energy that I'm gonna be producing annually, and then the same information I'm gonna have it here graphically. All right. Then I'm gonna be able to also get the single line diagram, as you can see here. And I'm gonna be able to generate it according to the information that I have introduced. One more thing is that here I'm gonna be able to print the drawing, but I'm not gonna do it now because it's the same thing that we did in the previous software. And since we are running out of time, so I'm just gonna go a bit faster. Then there is one more thing that here I would like to show you. It is gonna be the energy pre-designer. So this one is gonna be for you guys. So if you are doing your installation and before doing so, you want to do how much energy and how much you are gonna spend on your installation, you can select all the type of connection and introduce the production that you're gonna have each month and the consumption that you're gonna have. You're gonna see this information here graphically, and then you're gonna see here the energy that you're gonna be producing, the energy that you're gonna be demanding, and the rest of the information. Here also, you're gonna see all the cost of the installation and the amortization period, for example. All right. So then if you click on edit the cost here, you're gonna see the cost of your installation. Cost of your installation. Now, for example, here, if you are selling energy, you're gonna see that the amortization period is gonna change. Or, for example, if you click in the consumption and production analysis, you're gonna see how much energy you're gonna be producing, how much energy you're gonna be demanding. The same information is gonna be here, and how much energy you're gonna be using. So this is the energy that you're gonna be using, and the rest of the energy, which is gonna be the leftover. You can do two things with it. You can sell it to the distribution company, or you can accumulate it in battery. So that's how you're gonna get then your amortization period of the installation.
Okay.
Thank you very much for your presentation, Graeber. And as far as I can see, everything has the same word for all the time. So it's very easy to use. And as this is the end of the webinar, for all that those who have participated or registered, we have an exclusive offer on the software that we have presented today. And there you have my email, that is cristina.gomez@cype.com. Also, you have some specific question that you don't put in the chat. You also can send to Graeber to the support@cype.com or to the general cype@cype.com. Again, thank you very much for attending the webinar, and have a great day. Thank you very much for you also, Graeber.
You're welcome. And I would like to say something before finishing. And is that, as you said, for example, if you can see it, if you are working with any of our software, it's gonna be easier for you to start working with any other software that we have developed, because as you could see, the workflow and the interface is almost the same. So it is gonna be easier for you to start working with any of our software.
Okay, thank you very much.
You're welcome. Bye bye, guys. Have a nice one.
Bye bye.